Second, we also have transformations of exponentials. They follow kind of the same rules that we had for quadratic. So we have our general form, which is f of x equals a times b raised to the x minus c plus d. So each one of these numbers does something special to our graph. Let's start with a. If a is greater than 0, meaning positive, our graph is going to be pointing upward. Now, if a is less than 0, negative, our graph flips down. So this negative makes our graph reflect across the x-axis. Second, b. If b is bigger than 1, we have an increasing graph. If b is between 0 and 1, a decimal value like 1/2 or 1/5 or 1/3, then our graph is going to be decreasing. Up here in my exponent, if my x is negative, we reflect across the y-axis. C. For negative c, our graph shifts c units right. For plus c, our graph shifts c units left. Finally, d. For a plus d, our graph shifts d units up. For minus d, our graph shifts d units down. And those are our transformations. So let's take a look at this next example. Use the graph of f of x equals 2 to the x to describe the transformation that results in each function. Then sketch the graph. So what I did was I took this function here, f of x equals 2 to the x, and I plugged it in my calculator because this is acting as our parent function. Now I'm going to look at a first. So how did it change? So I started with 2 to the x, and I added in this plus 1. So in my exponent, I have a plus 1. So plus 1 means that it is going to shift c units left. So this graph shifts c, which is 1 unit left. And I would take this graph and I would move every point one place to the left. B. My x has become negative. That's the only thing that changed. Right away, I see it right here. B. Negative x reflects across the y-axis. So this graph reflects across the y-axis. So it's going to look something like this, somewhat. So it reflexes it across. Next, C. j of x equals negative 3 times 2 to the x. So first of all, I notice that the number in front has become negative, so I know it's going to reflect across the y-axis, the x-axis. But there's also a negative. There's also a 3. So what this 3 does is it does a stretch. And it is a vertical stretch. How did I know it was vertical? Because it's on the outside out here in front of the 2. If it was horizontal, it would have been next to the x. And that is it for transformations of exponential functions.